Good day, everyone. Today we will be discussing about Central Limit Theorem. Last meeting we discussed about sampling distribution of the sample mean, and it takes a lot of time for you to find the mean variance and standard deviation of the sampling distribution of the sample mean. However, with the use of the Central Limit Theorem or with the application of the Central Limit Theorem, we can find the mean, variance, and standard deviation of the sampling distribution of the sample mean in just only a limited time. Let's discuss. Central limit theorem. If all possible samples of size n are drawn from a population of mean mu and standard deviation sigma, and the sample mean and the sample mean x is calculated from each sample, then the frequency distribution of x has the following properties. First, its mean is equal to the population mean. What does it mean? It means that mu sub x bar is just only equal to the population mean. Therefore, if we can get the value of the population mean, then we will just simply copy the value of the population mean to the mean of the sampling distribution of the sample mean. Now, the second one is its standard deviation is equal to the standard deviation of the population divided by the square root of the sample size. It means that the standard deviation of the sampling distribution of the sample mean is equal to the population standard deviation all over the square root of n or the sample size. So by just applying this formula, we will be able to find the value of the standard deviation of the sampling distribution of the sample mean. For the third property, it will tend to have a normal distribution regardless of the shape of the population. Let's try an example. We discussed this problem last week, and it takes a lot of you, or it takes a lot of time for you to find the final answer of this example. The problem is again, a population consists of 5 values. 2 pesos, 3 pesos, 4 pesos, 5 and 6 pesos. A sample of size 2 is to be taken from this population. Find the mean, variance, and standard deviation of the given problem. So we're going to start identifying again n or the population and n which is equal to, or we denote that as our sample size. So the population is equal to 5 and our sample size is 2. Now after that, the first thing that we need to do is to find the value of the population mean, population variance, and population standard deviation. After doing that, we can now apply the concept of the central limit theorem or the properties of the central limit theorem in order for us to find the mean variance and standard deviation of the sampling distribution of the sample mean. Let's start with this table. So we have x, which are 2, 3, 4, 5, and 6 pesos. Now, the first thing that you're going to do is to find the summation of the value of x. So we're going to add 2, 3, 4, 5, and 6, and the answer is 20. So the summation of x is equal to 20. For x squared, we will just simply multiply x by itself. So 2 times 2 is equal to 4, 3 times 3 is equal to 9, 4 times 4 is equal to 16, 5 times 5 is equal to 25, and 6 times 6 is equal to 36. Now, after completing the value for x squared, what are we going to do? We will just simply add all the values on x squared. So 4 plus 9 plus 16 plus 25 plus 36, the answer is equal to 90. Therefore, summation of x squared is equal to 90. So since we already have or complete the given table, it is now our time for us to find the population mean. To find the population mean, we will just simply use population mean or mu, which is equal to summation of x all over n. Our summation of x is 20, so by substitution property, we will just simply substitute the value of summation of s, which is equal to 20, and capital letter n, which is equal to 5. By simplifying, 20 divided by 5 is equal to 4. Therefore, our mu is equal to 4. Now, the second one we will be looking for with this example is the population variance. For population variance, what are we going to do? We're going to apply this formula. Summation of x squared all over n minus mu squared. By substitution property, instead of writing summation of x squared, we will be writing 90. Why? Because summation of x squared according to our table is equal to 90. So therefore, instead of writing summation of x squared, we will be writing 90. That's the reason why it's 90. Now, instead of writing n, we will be writing the value of n, which is equal to 5. Bring down minus. Instead of writing mu, we will be writing 4 because according to our population mean is equal to 4. So therefore, instead of writing mu, we will be writing 4. Now, to simplify this, 90 divided by 5 is 18. Bring down minus. 4 squared is 16. Why is it 16? Because once you said 4 squared, that is 4 times 4. 4 times 4 is equal to 16. That's the reason why we have 18 minus 16. So our population variance is equal to 2. Now, to find the population standard deviation, so let's back this one. So we have 2 for population variance and 4 for population mean. To find the population standard deviation, we will be applying the formula sigma is equal to square root of sigma squared. Now, the value of our sigma squared or our variance is 2. So instead of writing sigma squared, we will be writing 2. So square root of 2 is equal to 1.4142. Take note, we need to round this up to 4 decimal places so that we can get the most accurate answer in our problem. So we already have n equals 5, n equals 2, mu equals 4, sigma squared is equal to 2, and sigma equals 1.4142. Let's rewrite that on our next slide. Let's write n equals 5, sample size is equal to 2, mu is equal to 4, sigma squared is equal to 2, and our population standard deviation, which is equal to 1.4142. Now, according to this one, to find the mean of the sampling distribution of the sample mean, we need to copy the value of the population mean. That is the first property of our central limit theorem. So if we're going to rewrite that, it will be mu sub x bar is just only equal to mu. So since mu sub x bar is equal to mu, and mu is equal to 4 based on our computation, therefore we can say that mu sub x bar is equal to 4. We just simply copy the value of the population mean. This is our population mean. Now, we already have the mean of the sampling distribution of the sample mean. The next one is find the standard deviation of the sampling distribution of the sample mean. We need to apply this formula. As you notice, on our central limit theorem, the formula is just simply sigma over square root of n. However, in our formula here, we have what we call finite correction factor. So we call this as finite correction factor. So why we use a finite correction factor? Or when are we going to use a finite correction factor? We use a finite correction factor when the population is given. If the population is not given, it implies that you will only apply the formula sigma over square root of n. However, in our given example, population is given, which is equal to 5. That is the reason why we need to use a finite or apply a finite correction factor. Now, let's do the substitution property. Instead of writing sigma, we will be writing 1.4142. Instead of writing n or small letter n, we will be substituting the value, which is equal to 2. Next, after substituting the value, instead of writing n or capital letter N, we will be writing 5. Bring down minus, and then instead of writing small letter n, we will be writing 2 because the value of the small letter n is equal to 2. Instead of writing capital letter N, we will be writing 5 minus 1. Now, we already have this one. After the substitution property is what I call the simplification. So what are we going to do? We will be dividing 1.4142 by square root of 2. So using your scientific calculator, it will be equal to 1. Why is it equal to 1? Because if we're going to divide 1.4142 divided by square root of 2 and round this up to the 4 decimal places, it will result to 0.99999. Then if we're going to round this up, it will be equal to 1. Now, how are you going to solve square root of 5 minus 2 all over 5 minus 1? So, you're going to simplify 5 minus 2, that is 3. And then 5 minus 1 is 4. So, it's just simply 3 divided by 4. So, to simplify this one, if we're going to use the scientific calculator and press this one, it will be square root of parentheses 3 divided by 4 close parentheses. Again, if you have just simply a normal scientific calculator or normal calculator, we can press square root of parentheses 3 divided by 4 close parentheses. And that is equal to 0.8660. So by multiplying 0.8660 by 1, it will be 0.8660. So therefore, our standard deviation of the sampling distribution of the sample mean is 0.8660. Now, to find the variance of the sampling distribution of the sample mean, we will just simply get the square of the value of the standard deviation of the sampling distribution of the sample mean. So instead of writing sigma sub x bar, it will be 0.8660, and then getting it squared, it will be equal to 0.75. As you can notice, the value of our mean, variance, and standard deviation of the sampling distribution of the sample mean are for 0.8660 for standard deviation and 0.75 for the variance. As you can notice, this is just only the same with the answer last week. So it's your choice if your teacher asks you about the mean, variance, and standard deviation of the sampling distribution of the sample mean. It's your choice if you're going to use the long method or the concept of the central limit theorem. Let's try another example. This is also our example last meeting. What are we going to do? We're going to start with, so the given table shows the monthly income of the officers. So we have 8, 12, 16, 20, and 24. Now the first step is again adding all the numbers on x value. So that is 80. So summation of x is equal to 80. Now the next step is getting the square root of the value of x. So therefore it will be 8 times 8 is equal to 64. 12 times 12 is 144. 16 times 16 is equal to 256. 20 times 20 is equal to 400. And 24 times 24 is equal to 576. The next step is adding all the numbers on x squared column. So 64 plus 144 plus 256 plus 400 plus 576, the result is 1,440. Therefore, summation of x squared is equal to 1,440. Now, to find the mean again, we will be applying summation of x over n. So, by substitution property, instead of writing summation of x, we will be writing 80, because 80 is the value of the summation of x. Instead of writing n, we will be writing 5. 80 divided by 5 is equal to 16. Now, to find the population variance, we will be applying the formula summation of x squared all over n minus the mean squared. Instead of writing summation of x squared, the value of the summation of x squared is equal to 1,440. And then instead of writing n, we will be writing 5. We will be having 1,440 divided by 5 minus 16 squared. Why is it 16? Because the value of our population mean is equal to 16. Now, by simplification, we need to divide first 1,440 and 5. 1,440 divided by 5 is equal to 228. Bring down minus. 16 squared is equal to 256. Once you said 16 squared, that is 16 times 16. Now, by subtracting 288 by 256, our population variance is equal to 32. Now, to find the population SD, we will be applying sigma is equal to the square root of sigma squared. Now, to find, we will just simply doing the substitution property. So instead of writing sigma squared, we will be substituting the value of sigma squared, which is 32. So we will be having sigma is equal to square root of 32. The value of the square root of 32 is equal to 5.6569. Again, I'm going to repeat. If we're going to find the sigma, we need to round this up to 4 decimal places so that we can get the most accurate value for our mean, variance, and standard deviation of the sampling distribution of the sample mean. Now, we already have the value of the population mean, population variance, and population SD. It's now our time for us to find the mean of the sampling distribution of the sample mean. By Central Limit Theorem, again, we will just simply copy the value of the population mean. Our value of population mean is 16. Therefore, our mean of the sampling distribution of the sample mean is equal to 16. Next. Now, to find our standard deviation of the sampling distribution of the sample mean, we will be applying the formula sigma over square root of n times the square root of n minus n all over n minus 1. By substitution property, it will be 5.6569 all over square root of 3 times square root of 5 minus 3 all over 5 minus 1. We need to divide 5.6569 by square root of 3 using your scientific calculator. It will result to 3.2660. Now, to press this one in your scientific calculator, we will be having square root of the parentheses 5 minus 3 is 2 divided by 5 minus 1 is 4. So we are getting the square root of 2 over 4. So if you're going to press that in your calculator, square root parentheses 2 divided by 4. Now the answer is 0.7071. By multiplying the two values, we can get the standard deviation of the sampling distribution of the sample mean, which is equal to 2 points, sorry, it's correction. It's 2.3094. Now, to find the variance of the sampling distribution of the sample mean, we will just simply get the squared of our SD. So it will be, by substitution property, it will be 2.3094 squared. 2.3094 squared is just simply 2.3094 times 2.3094. Therefore, our variance of the sampling distribution of the sample mean is 5.3333. Okay, so let's now proceed with the next topic, which is all about problems involving sampling distribution of the sample mean using the central limit theorem. So in this example, or in this concept or topic, we will be finding the probability of the given examples. So let's try. A population of size m is equal to 200, has mu equals 76, and a standard deviation of sigma equals 14. What is the probability that a random sample of size n equals 35 will have a 79 or more? So let's start with identifying the given. As you can see, the given are n equals 200, mu equals 76, sigma equals 14, n equals 35, and here we are looking for p of x greater than 79. So therefore, x is 79. So therefore, here are given, and let's rewrite n is equal to 35 and x is equal to 79. Now, what is the first step? The first step is we're going to apply the concept of the central limit theorem. So we will be applying the formula sigma sub x bar is equal to sigma all over square root of n times a finite correction factor. So by substitution property, instead of writing sigma, we will be writing 14. So here is the value of sigma. Instead of writing n or small letter n, our value of small letter n is equal to 35 times the square root of capital letter n, which is 200. That's the reason why it becomes 200 minus small letter n, which is equal to 35, all over 200 minus 1. Now, let's simplify 14 divided by square root of 35 using your scientific calculator. The answer is 2.3664. Now, to simplify this one, this finite correction factor, what are we going to do? Press the square root, parentheses. 200 minus 35 is 165, divided by 200 minus 1 is equal to 199. So thus, what are we going to do is to press square root of the parentheses, 165 divided by 199. And the answer is 0.9106. Multiplying the two numbers, we can have the sigma sub x bar, which is equal to 2.1548. Again, you're going to round this up to 4 decimal places. The second step is to apply the formula of finding the C. C is equal to x minus mu all over sigma sub x bar. Now, by substitution property, instead of writing x, we have x which is equal to 79 here. And instead of writing mu, we will be writing the value of the mu, which is equal to 76. All over sigma sub x bar. Your sigma sub x bar is your answer on the first step, which is 2.1548. Now, 79 minus 76 is 3, divided by 2.1548, the answer is equal to 1.39. Why this is not in 4 decimal places? Again, since the step 2 refers to the C value. So if we're referring for C value, we need to round this up to 2 decimal places. Now, after that, since we are looking for P of x greater than 79 based on the problem, and C is equal to 1.39, therefore, we are looking for C is greater than 1.39. So how does it happen? X becomes C and 79 becomes 1.39. Why? Because the value of C that we get on the step 2 is equal to 1.39. Now, so the first thing that we will be doing on the fourth step is to find the area that corresponds to Z equals 1.39. The area that corresponds to Z equals 1.39 is 0.91774. Now, since we're looking for greater than, there are three. This is just only a recall of what we learned on normal probability distribution. Now, class, so what are we going to do is this one. So we need to recall the concepts that we learned on normal probability distribution. There are three concepts. First, if it is less than, we will just simply copy as is. If it is greater than, we will just simply do the formula 1 minus the area. And if it is in between, we will just simply subtract the two areas. Now, in our example, since we're looking for greater than, we have 1 minus the area. So therefore, P of C greater than 1.39 is equal to 1 minus 0.91744. And the answer is 0.08226. By transforming the decimal form into percentile, it will be 8.226%. Why is it 8.226%? We will just simply move the decimal point ng dalawang beses on the right. Let's try another example. A variable is normally distributed with mu equals 100 and sigma equals 10. If a sample of n equals 16 is selected, what is the probability that the mean is less than 95? So let's now identify the givens. Or given it will be mean equals 100, sigma equals 10, n equals 16, and we're looking for p of x less than 95. So therefore, the given are mu equals 100, sigma equals 10, n equals 16, and x is equal to 95. As you can see, capital letter N is not given in the problem, or the population is not given in the problem. Therefore, the only formula that we can do in the first step is just simply sigma over square root of n. We will not be using the finite correction factor because the capital letter N or the population is not given. So by substitution property, instead of writing sigma, we will be writing 10. Instead of writing small letter n, we will be writing 16. By using your scientific calculator, 10 divided by square root of 16 is equal to 2.5. Now, the second step is again, we're going to apply the formula of Z. Z is equal to x minus mu over sigma sub x bar. So by substitution property, instead of writing x, we will be writing 95. Bring down minus, and then instead of writing mu, we will be writing 100 all over 2.5 because the value of sigma sub x bar, as we look on the first step, is equal to 2.5. Now, 95 minus 100 is equal to negative 5. Negative 5 divided by 2.5 is equal to negative 2. Therefore, we can say that C is equal to negative 2 or negative 2.00. Now, for the third step, since we are looking for P of x less than 95 and Z equals negative 2, therefore, we are looking for P of Z is less than negative 2. Now, the first thing that we will be doing on our fourth step is to find the area that corresponds to C equals negative 2 or negative 2.00. So the area that corresponds to Z equals negative 2 or negative 2.00 is 0.02275. Since we're dealing with less than, again, that is as is. So therefore, P of Z less than negative 2 is just simply 0.02275. Now, we need to transform the decimal form into percentile. Therefore, the answer is 2.275%. Let's try the last example. A survey found out that a fisherman catches an average of 13.6 kilograms of fish per week. Assuming that the standard deviation is 3.5 kilograms, find the probability that the mean of a sample of 60 fishermen will be between 13.5 and 13.8 kilograms. So as you can see, our given is average of 13.6 kilograms, standard deviation of which is 3.5, a sample of 60, and between 13.5 and 13.8. So therefore, we're looking for P of x greater than 13.5 but less than 13.8. Okay, so let's now write the given. U equals 13.6 because we're dealing with the average. Sigma is equal to 3.5, that is, we're dealing with the standard deviation, and n is equal to 60. Why we use the small letter n? Because we're dealing with the sample. If we're dealing with the population, we will be using capital letter N. Since capital letter N is not given or the population is not given on our problem, therefore we will be applying the formula sigma sub x bar is equal to sigma all over square root of n. Thus, it implies we're not going to apply the formula of the finite correction factor. By substitution property, it will be 3.5 divided by square root of 60, which is equal to 0.4518. Now, let's find the C value. For the first value of x, which is 13.5, it will be 13.5 minus 13.6, which is equal to negative 0.1, divided by 0.4518, that is equal to negative 0.22. Now, for the second value of Z is equal to 13.8 minus 13.6 divided by 0.4518. 13.8 minus 13.6 is equal to 0.2 divided by 0.4518. The answer is 0.44. So, thus it implies that we're looking for P of Z greater than negative 0.22 but less than 0.44. Sorry, this is 0.44. Okay. Now, what are we going to do is to find the area that corresponds to negative 0.22 and 0.44. So for 0.22, it is equal to 0.41294. And for 0.44, that is 0.67003. So by using the table or the C distribution table or the area under the standard normal table. So by using that, we can find the area that corresponds to a specific C value. Now, since we're dealing with between, we're going to subtract the two areas. So it will be 0.67003 minus 0.411294. The answer is 0.25709. Therefore, our final answer is by transforming the decimal into percentile, it will be 25.709%. That's all. Thank you and God bless. Okay, please don't forget to subscribe on our channel, hit the notification bell button so that you will be updated on our video tutorials. Thank you and God bless everyone.